Alright folks, hello, this is John DeRosa here from Verona, New Jersey, here to teach you how to use Desmos, and in this video tutorial we'll be looking at modeling motion with mathematics. So my favorite Desmos, or my favorite tool to use in Desmos is how to use Desmos to make objects move along sliders. So first we're going to import a couple of images that we're going to be using for this task. First I have a basketball. And I'm also going to choose a background. Notice when you import an image into Desmos, you can click and drag it to resize it, just as you'd like, and it'll appear over here in the taskbar. I've titled this basketball bouncing because that's what we're going to do. First, though, we're going to add one more image. We're going to have a background. I just picked out. We're going to have a basketball bouncing down the street. So the street, this background obviously can be larger, and if you notice, it hid the basketball. So where is the basketball? It's in our task bar over here, but we can't see it. And so if you want one image in Desmos to go in front of another, you're going to have to switch the order of the images. So by putting the basketball below the street background, the basketball will now appear in front. All right, so here's our basketball. And let's say we want to model its motion bouncing down the street. Okay. So first you're going to want to create a function or a curve or some type of relation that this ball can move along. Let's just use a simple flat line first. Let's just say, the line y equals 1, or we actually have to use function notation if we want to allow this ball to move interactively. Let's just say it's going to roll along this line. Okay, not too interesting a motion, but we just want to make this ball latch on to this function here, f of x equals 1 or y equals 1. So if we want that image to latch onto this function, we can go to the coordinates of the image, add a new parameter, say c, and then for the y coordinate it will be f of c. Now by adding c as a slider, we now have the case where the ball will move along this function. So if I go back here, I start the ball here and press play, you can see it's kind of like a rolling type motion. If you want to recycle the motion instead of oscillate, it'll go like there. And if you want, you can set the left part of the slider to 0 so that the ball will start right about there at the edge of the street. Okay, so we have our basic motion there just by using that third parameter c, and then f of c is the output there. So these coordinates are determined by whatever slider value you choose. As the value increases, well, then you're going to move further along here. The input will increase here 5.7. The output, f of c, is always 1 because f of x says it's 1. All right, so that's the basic motion in Desmos, how to make an object move. But we want it to bounce. Okay, so instead of f of x equals 1, why don't we use a sinusoidal function? Get a little more interesting here. Let's try this guy. F of x equals sine x, and we'll include a vertical shift here. In class, you can ask your students, think about the questions you want to ask them here. How can we change the model so that it will do what we want it to do? And if we do plus 8, that's a little too much, so we'll bring it down, maybe plus 1. Okay, and again, another opportunity to ask your students, what is wrong with this? Well, if we play this, a ball doesn't necessarily bounce like that. Maybe we want a little more of a vertical bouncing motion, up and down. And so what part of the function should we change? Here we'll change the period, and now it'll appear that the ball is going up and down. Okay, you can even mute the function there or turn it off so you can't even see it. You can slow the motion of the slider, and now we have a ball bouncing down the street. But you might notice that this motion is still not entirely realistic. Your students might pick this up as well. Because a basketball in real life, because of gravity, is not going to reach its max height each time it bounces. So it's really not that realistic to have it bouncing and still getting the same height each time it bounces. So to make this motion even more realistic, and this is a great question you're going to ask your students, you're going to have to introduce what's known as damped oscillatory motion, or a damped sinusoidal function, meaning we want it to get less and less each time, or the further you move, the higher the input values go. The further you move to the right, we want the y values to constrict, get closer together. And so what can you do here? Well, what do you want to mess with? in our function, and you might tell your students you want to mess with the amplitude. So this number here, if I make this really high, 333,333, it's going to go way up and way down. So by messing with the amplitude, that's going to affect our max height. And most students who've studied trig functions already know this. But what function? And here's what you need to ask them, because you want the amplitude to change as you move from left to right. So what function could we use here? What function of x could we insert for the amplitude such that the amplitude will be decreasing as the x values go from left to right? Okay, and they may not know what you're asking if you ask it like that, and so you might have to rephrase. You just say, well, can we think of a function that's decreasing as you move from left to right? Let's just think of any old function that's decreasing, and hopefully you'll get a hand up or two, and maybe they'll think of the most obvious one, negative x. And as we plug that in, you'll notice you do get an amplitude that's changing, but it's not in the way that you want. And perhaps you can ask your students to speculate. In this case, we can know that, well, as this number gets more deeply negative, say negative 10, well, then we just have a sine function with the negative shape, but it still has an amplitude of 10. So in essence, it's just going to be, oscillating up and down at slightly different points, but the amplitude is still going to be growing as you get more negative. Okay, so that's not going to shrink the amplitude. What we want then is an amplitude that approaches 0. So the next question to pose to your students is, can you think of a function with an amplitude that approaches 0? Or sorry, think of a function where the y value approaches 0 as you go further to the right, and hopefully someone will come up with an exponential function. In particular, an exponential function with a base between 0 and 1. And that's what I'm going to use here to indicate our damped oscillatory motion. So there we go. We have something that's changing as we wanted, but maybe it's not bouncing high enough at first, so you can alter the fraction here. Something like maybe even 0.9 or 0.8. Now this looks like a ball that's really bouncing. Okay, it gets less, but does it though? Because it's still kind of floating around. So to get rid of that float, instead of these nice smooth tranches here, or valleys, we want to create some sharp motion there at the bottom. So instead of those smooth valleys, maybe we can make that ball go down and down and up, down and up. And so to do that, you might have to think a little bit, well, how can we possibly make that happen? Well, I actually had a student who came up with this, and it was pretty clever. You can use the absolute value. Okay, so you just want it like this, where the absolute value is around the sine of 3x, and you can play around with the keyboard until you make that work. And now we should have a motion that looks much more realistic. Again, you can shorten the period if you think it should be bouncing more frequently. But take a look at this ball bouncing through the streets. That's pretty good, right? Compare that to the initial motion we had, and it's pretty realistic. You can see how to move beyond here. Perhaps you want to make this a piecewise function and then have it roll towards the end along the flat line. But this is just a starter's lesson on how to make images move and model 2D motion, which is my favorite thing to do with Desmos. If you want to make it look realistic, perhaps in a final product, you unclick all of the axes, you zoom to an appropriate level, and you can watch that motion just like you're watching a short cartoon. So there it is one more time. Okay. Thanks for watching this Desmos video tutorial. This is John DeRosa from Verona, New Jersey. Have a good day.